Hello and welcome to ESE Electronics. So this is a mock test series part 1 of GATE 2021 and ESE. So here we are going to see the solutions of the 10 questions which you have already answered in the 15 minutes. Okay. So each question carries 2 marks. We know that for GATE exams there are 2 marks and 1 marks. We'll be seeing the questions in the difficulty level for GATE and ESE. Okay. So total 10 questions were there. This is the first question. You can see the question's image in the board. I'll be writing the solution. Okay. So from today onwards, we'll be doing these various parts of mock test for GATE and ESE preparation. So you can find the previous year questions which were asked in the ESE exam and also in the GATE exams. These are not just random questions. These are actually previous year questions of GATE exams. And also if you are preparing for any competitive examination, you could attempt this mock test because it is very useful for you because GATE exams or GATE questions are very standard questions. Okay. And also if you want the notes of this video, that is the solutions, it will be available on the Facebook page of ESE Electronics. So please do follow the page. You can find the notes over there. Okay, so let us see the answer for the first question. So the question was actually the differential equation for the current I of t in the following circuit. That is, we need to find the differential equation for this given circuit. So the given circuit is having a source of sine t, then the current is I of t. There is a 2 ohm resistance, there is a 2 Henry inductor and a 1 farad capacitor. Okay, so I'm going to write the Kirchhoff voltage law in this loop. Okay, for this loop, I'm going to apply KVL. So how can we apply KVL? The source is sine of t. So sine t is equal to Ri. I'll just write the general equation first, then I'll be substituting the values of these elements. Okay, so R into I of t plus L into di of t by dt plus 1 by c integral I of t dt. So this is a KVL, voltage equation this is. Okay. Or you can write by substituting these values, you can write this is, okay, I'll write in the next step. Okay. So sine t is equal to 2 I of t plus 2 di of t by dt plus 1 by 1 is 1. So we can cancel it. Integral I of t dt. So this is the equation, KVL equation. Now we need to find the differential equation. So we need to differentiate this equation with respect to t. Okay. So if you write the differentiated version of this equation, I'll write it above for you to see it clearly. Okay. So I'm going to differentiate this equation with respect to t. Okay. And what will you get? You'll be getting differential of sine is cos. So cos of t is equal to 2 di of t by dt plus 2 d square I of t by dt square. Since it is a differential, so it will be square plus integral, take its differential. So you'll be getting I of t. Okay, this is the inverse of. Okay, so this is the differential equation. So this is the result if you differentiate the KVL equation, and in the option you cannot see this equation. You can only see di by dt, d square I by dt and I of t. So you can replace or you can rewrite this equation like this. Cos t is equal to 2 di by dt plus 2 d square I by dt square plus I of t. Okay, you can write in this form to make it actually available in the options, in the form available in the options. Okay, now I'm going to rearrange the equation as cos t is equal to 2 d square I by dt square plus 2 di by dt, just rearranging the terms. That's it. Plus I of t. Okay, so this is nothing but your option C is this where you can see 2d square I by dt square plus 2di by dt plus I of t equal to cos of t, or okay, I'll write it here itself to make it exactly equal to your option, is equal to cos of t or cos t. So this is option C. So the correct answer for your first question is option C is the correct answer. So what are we doing here? We are just writing the voltage law or the mesh law or the mesh equation for this particular loop, and we are going to differentiate that equation with respect to t. And then we'll be getting this equation. This is actually current equation, and this is the differential equation for current. Okay. So the correct answer for the first question is option C is the correct answer. The next question you can actually see on the screen. Choose proper substitutes for X and Y to make the following statement correct. Tunnel diode and avalanche photodiode are operated in X bias and Y bias respectively. You need to find what is X, what is Y. Okay, so from the given options, the correct option is option C, which is X is to forward and Y is to reverse. So which states that the tunnel diode is operated in the forward bias condition and the avalanche photodiode is operated in the reverse bias condition. Okay, so this is one thing which you need to know as a theory. Tunnel diode is always operated in the forward bias condition and avalanche photodiode is operated in the reverse bias condition. So the correct answer for your second question is option C is the correct answer. Question is question number 3, which is asking the Fourier series expansion of a real periodic signal with a fundamental frequency given by Gp of t. You can actually see the question on the board. Okay, so it is giving the fundamental frequency equation. Okay, and it is given that C3, that is C3 is equal to C3 is equal to 3 plus 5G, and you need to find what is C of minus 3. So you have been given the fundamental frequency equation. So in that the magnitude term is C. Okay, so the various frequency coefficients or the Fourier coefficients are C3, C minus 3, likewise it will go for a Fourier series expansion. You know that these are the coefficients, okay, for various Fourier terms. Now C3 is given as 3 plus 5G. Now what is C of minus 3? So how to answer this question is by double reading the question. Read the question once again. The Fourier series expansion of a real periodic signal. So there is the clue. The signal is real and the real signal is periodic. Now for a real signal or for a real periodic signal, there is one thing you should know for Fourier series also and for DFT also, discrete Fourier transform also, and all these expansion Fourier, DFT, DTFT, everything follows a rule called complex conjugate rule, where for a real signal you can write C of minus K is equal to C star of K. Okay, so you in DTFT, when you are expanding DTFT, you call this as complex conjugate property. It is one of the important properties of complex DFT equation, which is called the complex conjugate property. And this is also applicable for Fourier series. Here you can write C of minus K is equal to C star of K. Now you can also write this C of minus K as C of n minus K, since the signal is periodic. Now let us remove this term as of now. Just know that C of minus K is equal to C star of K. Now we want to find C of minus 3, right? What will be C of minus 3? It will be equal to C star of 3, right? Now just note this term, okay? Conjugate property. Okay, C of minus 3 is equal to C star of 3. Now we have C of 3 in our hand. C of 3 is equal to 3 plus 5G. Now how to find C star of 3? Star means conjugate How to take the conjugate of a complex number? Conjugate of a complex number is obtained by changing the sign of the imaginary term. So if this is C of 3, C star of 3 will be equal to, C star of 3 is equal to 3 minus 5j, and that is equal to C of minus 3. So this is the correct answer for your question, which is option D is the correct answer. Okay, I hope you understood how to do this question. It is by applying the property of Fourier series expansion. And since the signal is real and periodic, you can write C of minus 3 is equal to C star of 3. Okay, so hence you will be getting C star of 3 is equal to C of minus 3, which is equal to 3 minus 5g. Correct answer is option D. Next is the fourth question. You will be seeing the question on the screen. The question is the unit of del cross H. Now, how can you write del cross H? Del cross H is del cross H. You can write this actually a question related from, or a question from the subject electromagnetic theory related to the Maxwell's equations. Okay, we'll be doing a video on Maxwell's equations of EMT very soon in detail. So del cross H, you can write it as dou D by dou T plus J. Okay, so this is nothing but current densities, diffusion current density and drift current density. So this term in this side constitute current density. So its unit is actually unit of current density. So this is equal to, this means del cross H will have the unit of what? Current densities. Okay. Now, what is the unit of current density? I hope the concept is clear. Del cross H is equal to dou D by dou T plus J. J is a term used for indicating current density. This is also current density, diffusion and drift current densities. Okay. So what will be the unit of a current density? Current density means current by area is current density. Now what is current's unit? It is ampere is a unit, right? Ampere is a unit. Area is meter square. Standard units is meter. So it's meter square. So you can write this as ampere per meter square is the unit for this del cross H, right? Now from the options, the correct answer is option C is the correct answer, which is ampere per meter square. So just know that del cross H, its unit is equal to the unit of current density, and which is related by Maxwell's equations. So the correct answer for question number 4 is option C. C is the correct answer. The question is again from electromagnetic theory or EM waves generally. The depth of penetration of an EM wave in the medium having conductivity that is at a frequency of 1 megahertz is 25 centimeter. At frequency 1 megahertz, the depth of penetration is 25 centimeter. And what is the depth of penetration at 4 megahertz? So this is actually asking the skin depth. Okay, so you need to find what is the skin depth. First, delta 1 is given as 25 centimeters, and at frequency f1 is equal to 1 megahertz, right? Now you need to find delta 2, where f2 is equal to 4 megahertz. Now you just need simple relation between depth of penetration and frequency. Delta proportional to 1 by square root of f is the relation. So if you write the ratios of delta 1 and delta 2, you will be getting delta 2 by delta 1 is equal to square root of f1 by f2, right? Since it is having an inverse relationship, delta 2 by delta 1 is equal to f1 by f2. Okay, I hope it is clear. Now you have f1, you have f2, you have delta 1, you just have to substitute. So I'm going to substitute it. 1 megahertz, you can cancel off the megahertz and megahertz because both are same units. 1 by 4 into delta 1. Delta 1 is 25 centimeters. Now what is square root of 1 by 4? It is 1 by 2. That is 1 by 2 into 25 centimeters is the delta 2 value, which is equal to 12.5 centimeters is the depth of penetration, which is delta 2. Correct answer is 12.50, which is option B is the correct answer. I hope you have understood how to do this question, and you have seen the question in the board, I hope. That's why I'm not writing any questions because it is really time consuming to write the questions and options. So that's why I'm projecting the questions again on the board. Anyway, you can find the questions in the beginning also for answering purpose. Then you for the solution purpose also, I'm projecting the question on the board. Anyway, I hope you understood how to do this. So this is the question related to depth of penetration, and this is a relationship between depth of penetration and frequency of operation. Correct answer for this question is 12.5 centimeters, which is option B. Next question is question number 6, which is the resistance cube problem, which is a very famous question. You can find this question in a lot of question papers. This is a very famous question. Even if you study this question as by heart, then also there is no harm, because this is a tricky question, and if you don't know, it is time consuming. Okay, that is in the while answering in the exam hall, it is time consuming. But if you know the trick to answer this question, it is very easy. Also, I have explained another method in one of my previous videos, where I have explained some of the other resistance related questions also. I'll be sharing that in the description. Okay, please to check it out. In that, I have explained about the resistance cube very detailed. Now we'll be doing this question in a different approach. Okay, so you need to actually find what is the resistance between the two diagonally opposite corners of the cube. That is a question. So if you take two diagonally opposite corners, that can be this corner and this corner joined together, or this corner and this corner joined together, or this and this, or this and this. Okay, so that is a case of a cube. This is actually a resistance cube made of 12 1 ohm resistors. Now, how the current is going to split, we'll be seeing. Okay, then we will be applying KVL, and then we'll be solving this question. Okay, so I'm going to explain how the current is going to split. If you see this current, let the current is I. Okay, since all the resistors are equal, current is going to get split is equal across various nodes. Okay, so this is the first node I'm going to consider. The current I is going to split from this node to this branch, and this branch. Consider a cube. Imagine a cube. Only then you will be able to answer this question. So from this node, the current is splitting as 3 branches. So current is actually splitting as I by 3. Here I by 3. Here I by 3. Very simple, right? I is coming equally splitting across 3 equal resistors as I by 3, I by 3 and I by 3. Right. Now, consider this branch, this end branch. There is a node here. I'll be marking that. Okay. Node here. And in that node is this I by 3 is again getting splitted as 2, right? I by 3 by 2, which is I by 6, and I by 6. So I'm going to write it I by 6. Okay, so that is a current. Now consider the top edges I by 3. This I by 3 again getting splitted across this branch and this branch, right? How is it getting splitted? Here I by 6 and here I by 6. So I hope you can follow the path which I am following. So I3 is coming to this node and it is getting split as I by 6 and I by 6. Now take this node. There I by 6 and I by 6 coming and joining as I by 6 plus I by 6. What is it? 2I by 6, which is equal to I by 3. It is combining as I by 3, right? In this branch. Okay. Again, the same thing is happening. You can see here also an I by 3 is coming after combining this I by 6 together. Okay, so here also I by 3 is coming. Here also I by 3 is coming. So if you take this node, you can see I by 3 and I by 3 coming, and it is again joining I by 3, I by 3, I by 3. Sum is 3 I by 3, which is equal to I. Okay, so total current will be again I. So I hope this splitting of current is now familiar to you. Okay, so I is coming, getting splitted as 3, then again splitting as I by 6, here also splitting as I by 6, combining again forming I by 3, then I by 3, I by 3, I by 3 coming, combining as I. Now take the corners or diagonal points, this and this. Okay, so I'm going to take the voltage across or to this node as A and to this node as B. Now I'm going to apply KVL along the diagonal. Okay, I'm going to apply KVL. That is, if you take these two edges and combine as a loop, you can apply KVL. That's a concept. Even though I'm saying is applying of KVL along the diagonal, you can take it and form a loop. Only you can, that is, you can only apply KVL along a loop or a mesh. Most commonly, we only do that. So, just consider that you're taking all the resistors connected in the two diagonal points and you're taking it and combining and forming a loop. And then applying the KVL. Okay, so then it will be, let the potential across this A and B be VAB minus, you can see that what all resistors are coming in this path. I'll be keeping only those resistors and I'll be removing the other ones, okay, for you to make it clear. I don't need this for my loop. I need this, but okay, this I need, this I don't need. Okay, so I need only these many resistors when I take these points and form a loop. Okay, yeah. Now there's a VAB, which is a potential across this AB, minus there is a I/3 resistor here. You can see it here. See, this is the diagonal points. This is one point, this is another point, this is coming, and this is the next diagonal point. So these are two diagonally opposite corners. So there is 1/3 into 1 minus 1/6. There is one resistor along the path. So 1/6 into 1 minus it is not 1 by, it is I/3 into 1 is equal to 0. This is your KVL equation. I hope the concept of KVL equation is clear to you. Taking the potential across, if you join these 2 points, you'll be getting a potential, right? So that is VAB. You take it as VAB. Then there is a I/3 into 1. 1 is nothing but your resistance. So resistance into current is voltage. Again, I/6 into 1, voltage. I/3 into 1, voltage is equal to 0. Now, your VAB, if you take these to the other side, you can write, according to Ohm's law, VAB, the potential by current I is equal to Req, right? So take these terms to the other side. You can do it here itself. Plus VAB is equal to, take the i's common, I into 1/3 plus 1/6 plus 1/3. Okay, now as we have discussed earlier, you can write VAB by I is equal to Req, which is the equivalent resistance, which is the value which we need to find. We need to find the equivalent resistance across the diagonals. Okay, so Req, and that is equal to 1/3 plus 1/6 plus 1/3. What is that? It is 5/6. Okay, so the answer is 5/6 ohms. This is actually a very tricky question, but it's a very, very commonly seen question. As I've told earlier, I have explained another method of doing this question in one of my previous videos. Please to watch it. This is the resistance cube problem. Okay, that is connecting off or forming a resistance with all 1 ohm resistors or all identical resistors. Okay, anyway, the correct answer for your 6th question is option A is the correct answer. Okay, option A is the correct answer for your 6th question. This is the 7th question. The question is oscillator. Actually, you can see the question anyway and be saying it. So, oscillator circuit shown in figure has an ideal inverting amplifier. Its frequency of, that is the frequency of this oscillator. So, this is a RC phase shift oscillator, and the frequency of operation of an RC phase shift oscillator, this is actually theory question, 2 pi square root of 6 RC. Okay, So from the options, correct answer is option A is the correct answer, which is the frequency of operation of a RC phase shift oscillator is 1 by 2 pi square root of 6 RC. 7th question, correct answer option A. Question is 8th question. The action of a JFET in its equivalent circuit can be best represented as, correct answer is option D, which is voltage controlled current source. Okay, it can be explained or expressed as voltage controlled current source. So we all know that JFETs or FETs in general are field effect transistors, or they are voltage control devices. Okay, so the output current IDS or ID, for the case of a FET, JFET, it is controlled by the VDS or VGS, or the voltage you apply on the gate source terminal generally. So it is a voltage control device. So it is a voltage controlled current source. Okay, we know that FETs or FETs are generally voltage control devices and BJTs are current control devices. So here you have to consider that there is a voltage controlling the output current. So it is a voltage controlled current source. Correct answer is option D is the correct answer. An ideal sawtooth voltage waveform of frequency 500 Hz and amplitude 3 volt is generated by charging a capacitor of 2 microfarads in every cycle. The charging requires dash. That is, the question is, for charging this capacitor, what we actually require, whether we require a voltage source or a current source. Okay, so for finding out what we need, actually voltage source or current source, we will be seeing what is the voltage equation for a capacitor. Okay, so we can write VC, the voltage across a capacitor, is equal to 1 by C integral 0 to T I dt. Okay, so this is a very common equation, or the general equation for the voltage charging of a capacitor in terms of current. Okay, now the T, or the period of the wave, T is equal to 1 by F, right? What is F? F is 500 Hertz is the frequency, right? So 500, 1 by 500. 1 by 500 is equal to 2 milliseconds. So T is equal to 2 milliseconds, or you can write it as 2 into 10 raised to minus 3 seconds. So T is 2 into 10 raised to minus 3. And what is VC? It is given in the question that capacitor is charging to a voltage of 3. So the value of capacitor is also known. Now we can substitute the value of T here, and we can find the value of current, right? So 3 is equal to 1 by 2 microfarad, 2 into 10 raised to minus 6, 0 to 2 into 10 raised to minus 3 IDT, right? So you can write this as 3. So this is the term which we need to integrate. Okay, now we are going to integrate with respect to T. So 3 equal to 1 by 2 into 10 raised to minus 6 I into T, 0 to T. The term is integral 0 to T I dt, right? So it is a T, 0 to upper limit is 10 raised to minus 3, right? Now I'm going to substitute the limits. 2 into 10 raised to minus 6 I into upper limit is 2 into 10 raised to minus 3 minus lower limit is 0, so we can cancel it out. So this is the term which we get after integrating and after substituting or applying the limits. Okay, so I'm going to cross multiply this. It will be 6 into 10 raised to minus 6 is equal to I into 2 into 10 raised to minus 3. Now if you take this term and divide with this term, what will you get? 2 and 6 is 3. 10 raised to minus 6 and 10 raised to minus 3, you will be getting 10 raised to minus 3 here. Now you will be getting the value of I is equal to 3 into 10 raised to minus 3 or 3 milliampere, right? So from the equation, so what was our starting equation? It was Vz is equal to 1 by C integral 0 to t I dt, right? This is the starting equation. So this is the charging equation for a capacitor. Now from this equation, if we substitute the value of C, and if you found the value that after finding the value of t, that is a period of your waveform, you have obtained the current as I is equal to 3 milliampere. So for actually charging the capacitor, we require a 3 milliampere current source, which is a constant current source. Okay, so the correct answer for this question is, for charging, or the charging requires constant current source of 3 milliampere for 2 milliseconds. Now how we got as 2 milliseconds? Because that is the time period of the wave. So we have obtained t as 2 milliseconds, and also we have obtained I as 3 milliampere. So 3 millisecond constant current source for 2 milliseconds. I hope the concept is clear, and the correct answer for this question is option D is the correct answer. Okay. The 10th question is the minimum number of equations required to analyze this circuit. So the equation for finding the minimum number of loops or minimum number of equations is, there is a number of loops is B minus N plus 1, where B is the number of branches, N is the number of nodes. So this is the number of loops, and this much is the number of minimum equations we require. Number of loops is equal to number of minimum equations required to analyze a circuit. First, we'll be finding what is the value of B, then what is the value of N, and we'll be getting the number of loops. So number of branches. If you analyze the circuit, you can see that number of branches is, there is 1 here, 2 here, 3 here, 4 here, 5 here, then 6, 7 and 8. So B is 8. Then number of nodes. Number of nodes you will be getting as 5. Okay, let's check. 1, 2, 3, 4 and 5. Okay, so this is not a node, this is just a bending. Okay, so number of nodes N is equal to 5. I hope it is clear. So these are the number of nodes. 1, 2, 3, 4 and 5 nodes are there. Don't consider these as nodes. These are just bending of wires. Okay. So the number of nodes is 5 and the number of branches is 8. So 8 minus 5 plus 1 is 8 minus 5 is 3 plus 1 is 4. So number of loops is 4 and the minimum number of equations required is 4. Correct answer for the question is option B is the correct answer. So you require minimum 4 equations to solve this circuit or analyze this circuit. Correct answer is option B is the correct answer. So these are the questions which we have included in this video. I really hope that you found this video useful for your preparation of GATE and ESE examination, or for that matter any competitive examination of electronics. So please do share these videos maximum, and please do give it a thumbs up if you found these questions useful. If you could understand the solutions of these questions, please do give it a thumbs up, and please do share these videos maximum with all GATE and ESE aspirants. And if you want more videos, please do subscribe to the channel. Thanks for watching and keep on watching.